Hello friends, Schaff here again in another in a long line of award-winning trig YouTube videos. Friends, so far in other videos, we've covered the impact of the variables A alpha, B bravo, and D delta on the graphs of a sine curve, always in comparison to the original function. Some people call it the parent function, y is equal to sine x. So teammates, that leaves us with this last variable, C is in Charlie. Now again, I'm hoping you would activate your prior knowledge and just say to yourself, when you've looked at other functions like parabolas, when you had some type of shift that was co-located with your x, your input variable, wouldn't that shift bring you either left or right? Again, as a quick, simple example, let's go back to your days studying parabolas. Here's the original function, the parent function, y is equal to x squared. And if I said, well, what would be the impact of subtracting 4 from x and then squaring that difference? Teammates, the comparison would be that this function has its vertex at the origin. Parabola looking kind of like that. And what's the impact of the subtraction of 4 on this parabola compared to your original parabola? Teammates, subtracting 4 takes your original parabola and shifts it, moves it, formerly called a phase shift, 4 units to the right. Meaning, I know that my vertex here is at 4, 0, and my parabola looks something like this. And again, teammates, you can't escape the math, right? What is the smallest value that x minus 4 squared can be? The smallest value that can be is 0. When is it 0? When you input a value of 4 in for x, right? So teammates, it's a similar deal when looking at a sine curve. And let's get an example going. So teammates, let's say that I've got the function y is equal to sine x minus pi radians. Again, just by looking at this, again, the concepts are just the same as working with parabolas, the other functions you studied. I know that in comparison to the original sine curve, that this shifts the sine curve pi radians to the right. And again, the math makes sense. Like we could actually use a table of values to show that's true, but intuitively, I'm going to look at that. And if I'm asked to graph one cycle, I'm going to do something like this, teammates. I'm always labeling my axes, right? Again, just to refresh, x, input angles, y, the corresponding heights of the function, right? The output values. And teammates, for me, I always pick up where the function's been shifted. Those are the easiest functions to draw. So teammates, I know that this subtraction of pi tells me that a cycle is going to start at pi comma 0. What's the length of a cycle? Teammates, the length of a cycle is 2 pi radians. Again, how do I know that? From another video and some more learning that we're doing. I know that because the b value is equal to 1. So teammates, I'm going to call this 3 pi. Again, I've got my length of a cycle, right? 2 pi, right? 3 pi minus pi gives me 2 pi. And again, I am going to cut the axis into quarters for this cycle, meaning I'm going to find the midpoint, and I know that's 2 pi. And then for each half, I'm going to cut each half in half. Isn't that going to be 1.5 pi? And this is going to be 2.5 pi. Teammates, after that, I'll just plot some points and draw my graph. Teammates, I know that this is a true story with a happy ending, meaning I know subtracting of pi shifts my function pi radians to the right. But let's also just show it by using a table of values. And teammates, what input values do I want to use? I want to use these right here, kind of obviously, right? Meaning pi, 1.5 pi, 2 pi, 2.5 pi, and 3 pi. And teammates, let's get a unit circle going up here just to show that all of this makes sense from a math perspective. Now, teammates, let's do this and let's be smart about it. I know that the y component of all these points on the unit circle give me the sine of an angle, right? So maybe rather than writing the ordered pair points for these intercepts of my circle, maybe I'll just write down the y components. I know that the y component here is 0, it's 1 here, 0 again, and -1. Teammates, let's give it a go, don't you think? If I put pi in for x, I get the sine of pi minus pi. Well, pi minus pi is 0, and the sine of 0 is 0, which gives me an output of 0. Teammates, 1.5 pi in for x. Well, 1.5 minus 1 pi is half a pi. Where's half a pi radian in terms of an angle? Right there. Doesn't that give me a value of 1? Teammates, 2 pi in, 2 pi minus pi is a single pi. The sine of pi, again, pi radian, right? This angle right here, y component 0, 0. Teammates, you kind of see what we're doing, right? I mean, we're just making this trip around the unit circle with our terminal side rays. Frankly, if I'm going 0, 1, 0, right? 0, 1, 0. The only place now to go, right? Again, I've got that half of a sine curve. The only place to go now is to drop down here to the min value, right? Mathematically, it has to make sense, though. Doesn't it, teammates? Again, I put the 2.5 pi in for x. I do parentheses. That gives me the sine of 1.5 pi, same thing as the sine of 3 pi over 2. Isn't that angle this one right here? And again, I know the y component of the points on the unit circle correspond to the sine of the angle. Teammates, -1 and 0. And teammates, I've got this nice classic looking sine curve. Again, teammates, what's the deal with C as in Charlie? It tells you your left-right shift. Comparison, again, always in comparison to the original function, the parent function. Schaff out.